Hello and welcome to the Tech Geek podcast, folks. I'm your host Sukriti, and in today's episode, we will cover the future of connected devices, unlocking the power of AI and machine learning for a smarter future. Now, in this episode today, we will delve into the fascinating world of digital solutions for AI and machine learning in the field of connected technologies. From mobility and personal entertainment to large enterprises, we're going to explore the ways in which machine learning is being utilized to develop connected devices. I will also have a discussion with our guest today about the future of connected technology devices and how they're shaping the entire development of new devices and the user experience. Folks, I'm delighted to have Dr. Jay Ganesh, who is the Chief Product Officer of Digital Transformation Solutions at HARMAN, joining us today with me here. Jay is an accomplished leader in the field of digital transformation and innovation. With his extensive knowledge and experience, he's well positioned to offer valuable insight into the exciting and rapidly evolving world of connected technologies. Welcome to the show, Jay.
Thank you, Sukriti, and thanks for having me. I'm really excited to be on this discussion with you and looking forward to a great conversation.
Wonderful. So, Jay, I'm excited to actually ask the pipeline of questions that I have actually for you today. So, without any further ado, I would want to go ahead and begin with the first one. You tell us that what is the nature of digital solutions for AI and ML in the field of connected technologies? As you know, we are just going to start, establish this conversation today.
Right. So AI and ML has got a role to play across a variety of areas, and connected technology is one such. And the interesting thing about connected technology is that they are all about getting data from disparate systems. It could be devices, could be machines, it could be cars, even it could be any of the edge devices, etc. And given the fact that these systems capture data on an ongoing basis, it could be video, it could be log, it could be sensor data, etc. A tremendous amount of information is gathered and generated by these systems, which means that you need sophisticated mechanisms to understand, analyze, and make sense out of this data coming in from all these systems. So this is where AI and machine learning really plays an important role, because you need mechanisms to, for example, identify if there is an anomaly in the data coming in. You need intelligence to look at predictive maintenance type of scenarios in terms of predicting when a system can go wrong, or when a system can result in a behavior which is not expected out of that system. And these sensors and these devices in these distributed systems are collecting all this data, and this is where we build AI ML models on this data coming in from these systems, and analyze this data and make important insights based on all this data coming in from the system.
All right. Now, that being said, Jay, in what ways is machine learning being utilized to develop connected devices, including wearables, connected vehicle solutions, and IoT devices? Can you please share a few examples of these specific applications?
Yeah, machine learning as such is being used to make sense out of this data coming in from all these connected devices. For example, connected devices could be of the type for wearables, right? So these are the wearables like the watches, the fitness trackers, and medical devices, etc., smart watches, etc. All these devices have become much more intelligent. They have the ability to get data from the end user, or the system where this is being positioned, right? This could be about irregular heartbeats, it could be serious health conditions, etc. So these wearables, analyzing this data from these wearables is one way people are leveraging machine learning for. The second example could be around connected vehicles, right? So we have these vehicles on the road with various levels of ADAS maturity. It could be 1, 2, or 3, etc. And these vehicles are generating large amounts of data, including video data, radar data, etc. And this is where all this data is being analyzed by machine learning systems. It could be the sensor data generated from a LiDAR, for example, or it could be pedestrian, cyclist data, etc. So all this vehicle data is being used, and it is consumed by the AI ML models to alert the user or alert the central location for any abnormal behavior, etc. Then there are the third type of devices. These are about IoT devices, and these are devices which are your smart home appliances, industrial sensors, or energy management systems, etc., smart thermostats. They use AI ML models to analyze and make important decisions regarding the comfort of the user. The fourth one is smart city, right? So cities are becoming more smarter. There is more and more of video based sensors as well as audio and various types of sensors surrounding us. They capture a lot of data. A lot of it is can be used for better management of the cities, looking at areas like preventing crime or improving energy management, etc., etc. And finally, healthcare. This is another domain where the sensor data is being used to analyze medical data, right? So because a lot of these sensors from a medical device point of view generate images of patients. It could be X-rays, it could be various types of images, and AI/ML can be used to effectively analyze a lot of data coming from these systems as well.
Okay, thank you so much for those, references, Jay. Now, how can the game-changing capabilities of artificial intelligence help digital solution providers achieve unparalleled success? AI is the much talked about hyped solutions, technology, innovation that we are actually looking at this point in time.
Yeah, so AI and ML has the ability to make significant uh, success, has got the ability to facilitate significant success for digital solution providers because of the fact that there is large amount of various types of data generated. It could be unstructured data, it could be structured data, it could be semi-structured data, image, video, etc., etc. And a lot of the data which has been generated in this fashion can be utilized for making better decisions, including in areas like efficiency improvement, including areas like reliability, devising better experiences, insights to users, and finally, of course, innovation as well. Now, let's look at some example. For example, if you look at an area like improving efficiency and productivity, AI and ML models are very, very good at automating repetitive tasks, right? For example, if there is a certain task occurring on a very repeated basis, you can leverage machine learning models to automate a lot of these tasks. So these are examples of narrow AI where you use the machine learning models to target or solve one specific problem. It could be as simple as customer supports or queries regarding customer support or complaints from a customer, freeing up the bandwidth of the service executive to focus on more important tasks. Another example could be in improving the accuracy and reliability, because when you're looking at large amounts of data, the cognitive ability of the human being to process all this data can be limited. This is where the machine learning models can play a very important role to help the human make better decisions, which means that the human being can make decisions with lesser number of errors, and using machine learning you can reduce a lot of false positives. The third area is about personalization and customization, where I gave the example of AI machine learning is the ability to process large amounts of data from multiple data sources. So this is where personalization and customization is possible because you are combining data from multiple sources, correlating data from multiple sources to create a 360-degree experience for an end user. And that end user could be a customer, it could be a vendor, etc., etc. For example, a retailer can use a recommendation engine by combining the transactions data with behavioral data of the end customer. So you can essentially combine this data from multiple sources and create a very, very rich personalized experience. The next area is about predictions and insights, right? So, like I said, a good example of an insights and a prediction is using a machine learning models to identify frauds in transactions, or fraud in insurance claims prediction, or fraud in any financial transaction, etc. And all this will help in reducing the financial loss faced by the end user. And finally, innovation, right? So enterprises are always looking at ways to innovate, ways to unravel key insights from data, and this is another area where AI can play a very, very critical role.
Okay, so now when we talk about the entire strategy part here, Jay, what are the effective strategies and best practices for companies in building and training artificial intelligence models for these connected devices?
So the first strategy for any enterprise, regardless of which technology you're dealing with, AI is no exception, is to very, very clearly define the objectives you're going after, which essentially means that if you are going to go after building an AI/ML model, you should be very clear in terms of what that model is expected to solve and what are the key business objectives you're going after. Because you're once you build a model, and building a model is not a very easy thing, neither it is inexpensive. So you need to essentially justify a lot of the investments going in. So it's very critical to define what you're going after in terms of the outcomes and how the success of that particular model is going to be evaluated against. That applies for all technologies, not just for AI/ML. The next, when you're looking at AI/ML, we all know that particularly deep learning models need large amounts of data. So it is very critical that we have enough data points available to train the model, particularly when you're looking at identifying corner cases, the very high degree of accuracy. You need to expose the machine to as much of data as possible. That is high quality data. And that becomes very critical because getting this data and using this data to train the engine becomes very important in several other machine learning projects. The next is, of course, to identify the right machine learning algorithms to solve the problem. We all know that for solving the same problem, it could be a natural language processing problem, it could be a classification problem in the text processing space, etc. The same solution can be approached or attempted by using different types of algorithms and different types of training mechanisms. So it's important that we use the right machine learning algorithms for the problem at hand, and this comes with having a lot of exposure and a very trained data science team working on the problem. The next challenge is about data pre-processing and data pipeline. And I spoke about the quality of data earlier, but the quality of the data is not a one-time activity because businesses, when they're deploying these AI and ML models on a production scale, they will be running this model on a daily basis or an hourly basis, etc., which means that the data pipeline, which is feeding the quality data, needs to be very robust. It needs to be repeatable so that all the steps in terms of collecting the data, the pre-processing, the cleaning, ensuring that the data is free of bias in terms of noise, inconsistencies, etc., is taken care of. The next one is evaluation and iteration, which is all about doing the same steps repeatedly, move fast, evaluate, refine, because you're not waiting for the perfect model to come out at the end of 6 months. You're looking at models, improving the performance of the models, and iterating on an hourly basis in some cases, because there could be scenarios where you're looking at building a model and launching by the end of the day. And finally, monitoring and maintaining, because once a model is deployed, your job doesn't end there, because once a model is deployed, you need to monitor the model and maintain it. This is where we identify the drifts in the data. There could be data changing, the model is changing, could be model drift happening, etc., which means that a model which was built 1 year back needs to be is no more relevant today, or even models built a few months back may not be relevant today. And this is where you identify the drift, you identify the changes happening in the data sets, you identify the changes happening in the underlying behavior of the data sources, etc., and do this entire set of steps once again, right? So a lot of this happened through the processes we built around ML ops, which is about combining machine learning with operations, so that you can do a lot of the above steps on a repeated fashion on a regular basis, and most importantly, doing them on an automated fashion.
All right. So, Jay, you've spoken about how the entire digital solution is creating this buzz with AI and ML, and how the entire connected technology is being used. Right to strategies that you just spoke about. Let's talk about a little bit of the future holds. What do you think does the future hold for connected technology devices, and how will it shape the development of new devices and user experience?
The first trend you see, we see looking forward is in terms of increased connectivity, right? Not just in terms of the number of devices which are going to be connected, because we all know that the number of IoT devices, the number of sensors getting connected is growing at an exponential basis, right? So that is one. In addition to all the mobile phones and all the connections, the industrial AI is growing at an exponential pace. So one trend definitely is increased connectivity. The second trend is about the quality of connection. We all know that we are at a phase of 5G, and there are companies who are already testing 6G, which is going to be the next level of connectivity. So that level of connectivity is going to facilitate more amount of data being transferred, more better experiences for the end users. Second trend, the third trend is about better intelligence, because uh, the the ability of AI ML models are improving on a regular basis, because we all know that we have at a stage of deep learning and generative AI. More and more of connected devices are generating larger amounts of data, and we are also at a stage where we are increasingly using AI ML for better intelligence, better automation, personalization. So a lot more of advanced AI models are being built. The next trend is about security, because of the fact that these IoT devices and sensors are prone for a lot of cyber attack. In fact, if you look at several of the cyber attacks in the recent past, a lot of the entry points were through the IoT devices, whether it is misconfigured password or very loose security policies in place. So enhanced security is going to play a is going to be a very important trend for the future. The next trend is about immersive experiences. Given the fact that we are already in a 5G world and moving towards more of 6G, the level of virtual and augmented reality experiences are going to go up for end users. And because of the fact that they're all connected, the ability for end users to be in more immersive environments, virtual worlds, remote training, all those things are going to be extremely interesting going forward. And finally, there's going to be increased focus on sustainability with all this technology changes happening around the world, in terms of how does the power consumption be used in all these distributed systems. And these systems needs to be built with sustainability in mind, not just from a hardware perspective, but also from a software perspective, because there are recent studies which show that certain types of softwares running in systems have an ability to consume much less power than certain others. So it's a combination of hardware and software coming together to have a better sustainable future while leveraging all these technology progresses we see on a day-to-day basis.
Amazing. Now, the last question, I would like to wrap up with one of the most important elements when we talk about the digital solutions and the entire technological innovation that's happening all around the world, which is like cybersecurity. Jay, how is the power of machine learning leveraged in digital solutions to fortify cybersecurity?
I spoke about security and cybersecurity becoming extremely critical, and given all the connected endpoints we are getting surrounded with, right? So because cyber attack entities are always looking at any entry point from a customer's from an end user's systems perspective, and usually the IoT or the sensors or the wrong configured passwords becomes one of those entry points which is being exploited maximum number of times. Now, AI ML models can be used to create very strong defense mechanisms against such attacks. The first one is, of course, anomaly detection. I spoke about anomaly detection earlier in a different context, but AI machine learning models can identify anomalies in the network traffic or user behavior. An anomaly is where you find a data set or a system behaving in a fashion it is not supposed to behave, right? So, for example, if there is a unwanted entity playing around with your systems or is in your network, they will behave, that entity or that agent will behave in a manner which is different from the usual behavior of the system. So an AI machine learning model or a machine learning model built for identifying an anomalous behavior in the data can quickly identify and tag this suspicious behavior, which can further be checked up by the security teams. The second type of cybersecurity AI/ML models people can look at is in terms of predictive analytics space, right? So we all know that we have large amounts of data created through the various systems, connected devices, log files, etc. You can leverage a lot of these data points and correlations to essentially predict certain events even before they occur, and This is very much possible because you have a connected view of the data. You can use graph theory based approaches, graph based approaches to identify the connected devices in the system and even predict which part of the system can get impacted if one part of the system is affected by an attack. So this is where a combination of machine learning and graph theory comes into place, where you can isolate a certain part of the network even before an attack spreads to that part of the network. The third area is about malware detection, because we all know that malwares are spreading, and there are mechanisms being put for identifying malwares, and this is all about using machine learning algorithms to identify patterns in behavior of the malware. So it could be about the way the malwares are communicating, or the way the systems are where the malware files are being transferred from various systems. So you can essentially use machine learning models for identifying behavioral patterns or changes in the behavioral patterns. The next is about better user authentication, because we all know that user authentication is the first step for entry into the system by authenticating a user, right? So this is where you can combine, the traditional user authentication mechanisms to more of pattern recognition, identifying the behavioral pattern of the user, the mouse movements of the user, right? So how the user essentially behaves on a regular basis, not just the password and the facial recognition, etc. So a lot of those nuanced mechanisms can also be built in to identify if the user is who or he or she is claiming to be. And finally, network segmentation, right? I spoke about graph theory based approaches for analyzing networks. And this can also be effectively used in network segmentation, where spread in one part of the network of a malware or a virus in one part of the network can effectively be used to predict what can happen in some other part of the network and isolate that network component. So these are some of these ways by which we can leverage AI machine learning for improving our cybersecurity posture in enterprise scenarios.
Fantastic. Thank you so much, Jay. I think you gave us some very, very useful insights that actually not only the techies but the businesses can also look at when it comes to using the connected device, and how the exact the connected device would be in terms of user experience, and would actually look like in terms of current scenarios and moving forward. Thank you so much for being a part of this conversation, Jay.
Thank you, Sukriti, and thanks for having me, and thanks for listening to this podcast, and thanks for all the interesting conversations.
Thanks, Jay, once again, folks. Thank you so much for tuning in, and I hope uh, you're just excited to listen to what Jay shared about the rapidly evolving world of connected technologies, and how does it look like, what it holds for not only the businesses but for you. Stay tuned to TechGeek for more such tech podcasts. I'll be back with another episode very soon. Till then, stay safe and take care. Thank you so much, Jay, once again.
Thank you. Bye then.